Okay, in this series of questions, we are going to set up a function simply by being given some information. So it's building upon kind of what we've already been doing. Question 45. We're writing an exponential function with an initial value of 110 and a growth rate of 3.5. So the function is f of x. It could be f of t. Watch when you're doing your homework which one it's asking for. Initial value always goes here. The percentage goes here. Remember, it includes 100%. So if it's an increase, it's 100 plus the rate. So in this case, we have a growth rate. So 3.5. So it's 100 plus 3.5, 103.5. Divide by 100, so it's going to be 1.035. The initial value is 110, and x up there for the exponent. And then as we take that change, a 3.5% change, these are percentages, over time, 1 year, 2 years, 3 years, 4 years, that's what the exponent becomes. So here's 46. 46, we've got an initial value. We start off with this function notation of 1,504. It always goes first. That's what we're starting with. And we're going to have a growth rate of 12%. So again, drawing on everything we've done, that's 100 plus 12, 112%. 1.12 is our factor raised to the x power. Okay, so that x is going to be a number. It's going to be 1, 2, 3, 4. 10 years down the road, we will be able to figure out what 12% of 1,504 taken over 10 years gives us a lot of power. And this is building us up for the next few chapters, which are going to deal with financial math. 47. Let's read through this. Another exponential function. So we go with f of x. We could go with g of x if you get tired of f of x. Why not? We've got an initial value of 63, and this time we have a decay rate. We are losing value. We start with 100%, we're losing 28%. So we're only going to get back 72%. So as a factor, divide by 100, that's 0.72. There's our exponent for how many years we have that loss, and there's our function. 48. We've got a function. Well, let's go ahead and go with g of x. Again, whatever they give us we'll use, but just variety. We've got an initial value of 545. That goes in the front. And a decay rate of 0.4%. Now this is a little tricky. 100% minus 0.4%. So not losing much, but we're losing some. So when you do the subtraction, this is 99.6% that we're getting back. Again, move the decimal over 2 places. What we should have here is 0.996 is our decay rate. And there's our exponent for the number of times that happens. And we'll finish off here in this series with 49. G of x. We've got an initial value of 79, and we're growing by 119%. So that means we start off with 100 and we add another 119. So 100 plus 119 is 219%. So we move it over 2, and we get 2.19 is our factor. Very good. Well, while we're at it, let's continue here with 52, and we get a little bit more details to working out these problems because we've got an A part and a B part. First part is to come up with the function, and the second one is to use that function. Okay, so let's go ahead and change colors here. 52. So the question for 52A, they want us to write a function, go back to f of x, it starts out with 1,944 organisms, and it's increasing by 5.2%. So that is 1.052, 100% plus 0.52 raised to the x. Okay. The b part of the question is to take this function and figure out what happens after 7 years or 7 days or whatever. 7 years. So we plug in 7 there, 1944, using the function 1.052 raised to the 7th power. Okay, so put it in your calculator, and what you'll see is you'll get the answer that f of 7 equals 2,772. .53. The a part is to write the function. So we start off this time with 17,000 organisms, and we're increasing by 8% a year. Decrease. Important words to look for, decreasing by 8%. So what's that going to look like? That's going to be f of x. We start off with 17,000, and notice I won't put the commas there because you don't use those with a calculator. Don't put commas on your calculators. They don't like it. Okay. We're decreasing by 8%, so we start with 100 minus the 8. That gives us a 92% return come back to us, so it's a 0.92 as our function factor. So the B question is going to ask, what is f of 2 years down the road? How many organisms are we going to have? Well, it'll be less than 17,000, right? Because we are decreasing. That's one way to check. And getting up in this exponent is going to go with the number 2. So we put that in our calculator, and we see we get 14,389. We lost 8%. .54. Again, the A question, we're told that we have a beginning value of 16,000 in our account. I guess we should put the function f of x equals 16,000. That's what we started with. Or she started with, Rose, and she's going to get 3.6% return on her money every year. So that's 1.036. There's our function. And we want to know, well, I guess they didn't ask that, but we need this because then they want to know what's the value in the year 2032. She put it in 2014. So we need to know how many years passed by. The way we can do that is take 2032 and subtract 2014. So subtract the 2 years, and what we see is we get 18 years. Makes sense. Born 18 years later, going to college, great. So we use this function, and what we're doing is we're finding the function value after 18 years. Again, we use the whole thing, and this is going to be kind of our introduction to financial math. We'll be doing this a lot. Or the results are kind of going to look like this. Put the 18 up there, and what we get is that Rose has saved over those 18 years. There's now $30,000, $30,240.96 in her baby's account to go to college with.